Hi, I'm Pavithra from the Department of Artificial Intelligence and Data Science. In this video, we are going to see about digital system design experiments. Now we are going to see the fifth experiment, design and implementation of parity generator. Parity generator. A parity generator is an extra bit included in the code word to make the n total number of ones either odd or even. An even parity generator utilizes odd function to make the number of ones even, vice versa. Example of parity generator and truth table of parity generator, and there are also logic diagram for parity generator. Let's check the simulation for parity generator. So this is parity generator. This is how we should give the connection. Here for parity generator we need 3 inputs and it gives 2 outputs, that is odd parity and even parity. First we name 3 inputs as A, B and C. We have to take one XOR gate and we have to connect A and B to the XOR gate. Next we have to take another XOR gate and connect A, B to XOR output and C, and then next we have to connect that output to light, that is even parity. Then we have to take one NOT gate and connect A exclusively C to that NOT gate and connect that to the light, and then it's odd parity. The input is 0 and 1, odd parity is 1 and even parity is 0. If the input is 1, odd parity is 0 and even parity is 1. Next we are going to see the seventh experiment, design and implementation of encoder and decoder. Encoder, a digital circuit that produces a binary output code depending on which of its inputs are activated. Decoder, a digital circuit that converts an input binary code into a single numeric output. Now let us see the simulation for encoder. Let us check whether our simulation is working properly or not. Let y1 be 1 and others be 0. The output must be A should be 0, B should be 0 and C should be 1. Next, let us give y7 as 1 and others as 0. The output should be A should be 1, B should be 1 and C should be 1. And let us give y4 as 1. The output should be A must be 1, B must be 0, C must be 0. Yes, our simulation is working properly. Let's check the simulation for decoder. A, B, C are the inputs and here are the outputs. If B is 1, D1 is 0 and others are 1. If A is 1, D2 is 0 and others are 1. If A and B both are 1, D3 is 0 and others are 1. Here is our final experiment study of flip-flops. Flip-flops. A flip-flop is a bistable device, a circuit having two stable conditions 0 or 1. Three classes of flip-flops: latches, pulse triggered flip flops, and edge triggered flip flops. Latches. Outputs respond immediately while enabled, no timing control. Pulse triggered flip flops. Outputs response to the triggering pulse. Edge triggered flip flops. Outputs responses to the control input edge. What is JK flip flop? A flip flop is a circuit that has two stable states and can be used to store state information. The flip flop can be made to change state by signals applied to one or more control inputs and will have one or two outputs. Let's check the simulation for SR flip flop. S and R are the two inputs connected to the SR flip flop, and output Q and Q dash connected to the SR flip flop. If S is 1, Q will be 1 and Q dash will be 0. If R is 1, Q dash will be 1, Q will be 0. R and R are 1, Q and Q dash both are linked together to the clock.